Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. X1, X2, and X3 is a random sample from the exponential distribution with mean 1. Let y1, y2, and y3, where the subscripts are in parentheses, be the corresponding order statistics. Find the variance of the second order statistic. Here is the solution. So we have S sub y1 of y equal to the probability that y1 is greater than y. And the first order statistic is greater than y if and only if every single piece of the random sample is greater than y. So this is equal to e to the minus 3y, so that y1 is exponential with hazard rate 3, and f sub y1 of y is 3e to the minus 3y. On the other hand, f sub y3 of y is the probability that a capital F, so the cumulative distribution function, is the probability that y3 is less than or equal to y, and that means that the maximum of the three is less than or equal to y, and that means that every single one of them has to be less than or equal to y. So this is equal to the probability that y1 is less than or equal to y times the probability that x1 is less than or equal to y, times the probability that x2 is less than or equal to y, times the probability that x3 is less than or equal to y. And that's equal to 1 minus e to the minus y cubed, and that's 1 minus 3e to the minus y plus 3e to the minus 2y minus e to the minus 3y. Then we take the derivative of that, and we get the little f sub y3 of y equal to the derivative of what we just calculated, and that's equal to 3e to the minus y minus 6e to the minus 2y plus 3e to the minus 3y. And now we use Pusticks. Pusticks tell you that the sum of the probability density functions of x1, x2, and x3 is the same as the sum of probability density functions of y1, y2, and y3, because in aggregate they are the same thing. It's only that we get y1, y2, y3 by ordering the pieces of the sample. And therefore, f sub y2 of y is f sub x1 of y plus f sub x2 of y plus f sub x3 of y minus f sub y1 of y minus f sub y3 of y. So that's equal to e to the minus y plus e to the minus y plus e to the minus y minus 3e to the minus 3y minus 3e to the minus y plus 6e to the minus 2y minus 3e to the minus 3y. And after we cancel out things that cancel out, we obtain 6e to the minus 2y minus 6e to the minus 3y. Now you could also use the general formula for the PDF of the order statistics. Let us write x for general exponential random variable with mean 1. Then using that general formula, f sub y2 of y is 3 factorial divided by 2 minus 1 factorial times 3 minus 2 factorial times f sub x of y to the power 2 minus 1 times s sub x of y to the power 3 minus 2 times f sub x of y. That formula is in my study manual. You should know it, and it's discussed and explained there. So this is equal to 6 times 1 minus e to the minus y times e to the minus y times e to the minus y, and that ends up being 6 times e to the minus 2y minus e to the minus 3y. It's the same value, of course, as we just obtained using Pusticks. And therefore, e of y2 is the integral from 0 to plus infinity of y times the density we just calculated either way. Well, we put the common factor of 6 in front, and what we have then here is 1/2 of the integral from 0 to plus infinity of y times 2e to the minus 2y dy, which is the mean of exponential random variable with hazard rate of 2, and that mean, of course, is equal to 1/2. So this is really 1/2 times 1/2, so a quarter, minus 1/3 times the integral from 0 to plus infinity of y times 3e to the minus 3y dy, and that's the mean of exponential random variable with hazard rate of 3, which is 1/3, so this is really 1/3 times 1/3. So what we obtained is 6 times 1/4 minus 1/9, and that's equal to 5/6. And then the second moment is calculated as the integral from 0 to plus infinity of y squared times 6 e to the minus 2y minus e to the minus 3y dy. And we rewrite this as 6 times 1/2 times the integral from 0 to plus infinity of y squared times 2e to the minus 2y dy. This is the second moment of the exponential distribution with hazard rate of 2. And the second moment is equal to the variance of that random variable, exponential with hazard rate 2, and the square of the first moment. And so what's the variance of exponential with hazard rate 2? It's 1/2 squared, the square of the first moment. I'm sorry, this variance is, right, the variance is a square of the mean. Variance is the square of the first moment. And therefore, what we have here is 1/2 times 1/4 plus 1/4. In other words, the second moment plus the square of the first moment. I didn't say it right. The variance plus the square of the first moment. So 1/4 plus 1/4 is the variance plus the square of the mean. And then we subtract 1/3 of the integral from 0 to plus infinity of y squared times 3e to the minus 3y dy. And then, of course, 3 times e to the minus 3y is the probability density function of exponential distribution with hazard rate of 3. And therefore, this whole expression is the second moment of exponential distribution with hazard rate of 3, and the second moment is equal to the sum of the variance of that exponential distribution and the square of the first moment. The variance is actually the square of the first moment of the square of the mean, so it's 1/9, and then the square of the mean is 1/9. So this becomes minus 1/3 times 1/9 plus 1/9. Okay, we multiply it all out and becomes 6 times 1/4 minus 2 over 27, and that ends up being 19 over 18. So the variance of y2 is this second moment, 19 over 18, minus the square of the first moment, and that square is 25 over 36, and therefore the answer is 13 over 36. That's answer B. Please remember, this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.